Okay, this is on sig figs, and for multiplication and division, you report the result to the same number of sig figs as the least precise. So same number of sig figs. And you should already know how to do this, but I'll go over it again. Here we go. 3.05 times 2.5 divided by 3.751. This number of sig figs in this one is 3. Number of sig figs in this one is 2. Number of sig figs in this one is 4. So I will report my result to 2 sig figs. My value is going to be 2.0328, which ends up being 2.03. Now, sig figs are not going to be important on exams as long as you give me enough. They are, however, going to be very important in the laboratory, in the lab write-ups, okay? And that's where we'll worry about them. For subtraction and addition, we'll write the rules down. So here we go. For subtraction and addition, we're going to report the result to the same precision, not the same number of sig figs, but the same precision as the least precise value. So, for example, if I have 8.517 plus 2.4, my value is 10.917. What is the least precise? It is this digit, so I'll report my value to there. This becomes 10.9. Make sure you round correctly. Okay, so that's sig figs for multiplication and division and subtraction and addition. I'm going to do logarithms here. You need to know how to do that. It's not hard. Okay, so when we take the log of a number, for example, suppose we have 575. That has 3 sig figs. When we take the log of 575, we get an answer that is 2.7596. This is called the characteristic, and this is called the mantissa. We are only reporting sig figs for the mantissa. This is not significant here. Okay, that's a decimal holder. It means times 10 to the second. Okay, so it's not anything to do with significant figures. So I'm going to report with these the same sig figs as in my original number, which is 3 sig figs. So get 3 sig figs. The first one is not significant, 2, and so I go 760 when I round, okay? And so this value would have 3 sig. Now we'll do the reverse log. Okay, I've set up an anti-log. Here's my value, 3.598, and then I'm taking the anti-log. So this digit here, the 3, is a number that's telling us times 10 to the third, so it's not significant, and these 3 are. So when I take the anti-log of 3.598, 10 to the 3.598, I get this value, and I should have 3 sig figs. So I'd have to report this 2.07 times 10 to the third. I'm not going to accept 2070. I'm not going to accept that because I don't know whether that 0 is significant or not. Okay, so if you're in this situation, you got to force it into there, into scientific notation. That's it for sig figs. One other thing about sig figs. We use sig figs when we don't have any information about the error. We, for the most part, will always have information about the error. We'll talk about that in the lab some more.